Welcome back guys. So here I will talk about all remove method of hashset classes, right? Like what are the methods we have to remove the object from the hashset class. So we will see that one by one. So I'll do one thing, I'll write a main method first, because you know that main method is the one from where your actual execution of program will start, right? So let me create the object of set class. So I'll write set control space bar, click control space bar, import this Java util package. You can see that your set interface got imported here, and here I'm going to store integer object is equal to, just do control space bar, set, and do new, and then hash it. Okay, so first I will do one thing, I will add some data in this. Sorry, I did a mistake. So I will add set dot add, and let me do one thing, let me add a string. Here also let me add a string. So here I will add test1, test2, test3, test4, and test5. So you have this data added. Now you are going to perform remove operations on that. So when you say dot remove, you can look at here, you have couple of method for remove. You have this one, second, third. So there are basically three remove method you have. One, what it will do, it will remove the object. So first I will go for this remove, and I will tell you how this will work. So when you do remove test1, let's say you are doing the remove of this object. So when you do that, when you press control and go to the remove method, okay, generally what happens is this remove method, it is coming from where? It is coming from the set interface. Okay, this is coming from the set interface. Now there should be a class which should have the implementations, right? So go here again, this is coming from set, right? So there should be the class which has the implementations. Now go to the hash set. This is the class where you will have all the implementations of this set class, right? Set class where you will have all the implementations of this set interface. Now go to the hash set, and in the hash set, when you do here, do control O and type here remove. Okay, so this is the implementations for remove. Click on that. When you click on that, you can see that this will remove from the map. Okay, this will remove from the map, and by now you are familiar of how the data add happens in case of map, right? So this is our bucket of size 16, and that's how the data we add, right? We add data based on the index. On the index, wherever we get a hash code, these are the hash code for the object which we are going to add, which I have shown you in multiple times. So we calculate the index for the hash code by doing a modulus 15. So whatever, let's say if I have a hash code of this big number 1 2, if I will do modulus of 15, I will get some index, and this index will come between 0 to 15, right? Why? Because I am doing a modulus of 15. So whenever you do modulus of 15, your index will never cross 0 to 15. Okay, and you know that map, when you create the object of map, it has a default size of 16. Since it is starting from 0, we can write 0 to 15, and that's how we add the object in the map, right? Because every index, wherever the index will match, one node will get created and the node will get added. Node will have the address, data, and the next pointer. As of now, this all next is pointing to null. So whatever you are seeing, that all next is pointing to null. So let's say you have data in the map. Now you are going to perform remove operations. So when you are going to perform remove operations, what will happen? The data will get removed from the map. Okay, Now when the data will get removed from the map, what happens? Click on control, click on remove. So when you will click on that, look at the interesting part here. All concept remains same. Again, for the key which you are going to remove, the key is what? Object. The object you are going to remove. For that, again the hashing will get created. Again it will create a hash. Okay, and you know that hash is a method which it will create, it will generate the hash for your object. So basically internally it will call a hash code method, and it has some logic. Okay, it will generate some number. This number, what it will generate, that we should not bother, we should understand the concept. So what happens? Hash code got generated. Once the hash code got generated for the object which you are going to remove, basically, so you got the hash code. Now for the hash code, again what happens? Index will get calculated. Okay, and actually if you read the entire things, you will come to know why this hash code is required. It is never to be used in the index calculations because of the table bounds. So if you read all the comments whatever they have given, why this hashing is required, you will come to know. So for the hash, which I have told you earlier, for every hash code the index it will get created. Okay, the same thing will happen again even in case of remove. For the hash, let's say you got a big hash number. Okay, for the test one, what will happen? For the test one, you will get the same hash code 80698815. So the program will do modulus of 15. They will get index is equal to 0. So when they will get index is equal to 0, you know what happens in the memory? It will go to the 0 index in the bucket, and 0 is pointing to one node, right? So 0 is pointing to one node. So actually 0 dot next actually, if you technically ask me, 0 dot next is nothing but this object test1. Okay, when we call remove, you know what will happen? 0 dot next will point to null, and this object whatever you are seeing, that this will get dereferenced. And this will be removed by the garbage collector once this object is not referenced. Okay, that's how the remove happens. Clear? You got how remove works? So that's how remove works. So no matter how many remove you do, it will work in the same way. First, for your object, wherever you are performing the remove method, for your every object the hash code will get generated. It will create the index. It will go check in the bucket. If bucket has the object, your object will get pointed to the null. This is one method, right? Now similarly what you have here is, let me create one more and let me write here set1. Okay, so what I will do is, I'll remove this. Okay, and here when you perform this set1 dot remove all, so there is a method called remove all. So in remove all, if you will just point to set1, and when you go and when you print this set after removal, okay, so let me print 3 times, one before removal, one after test1 removal, and then one when we are removing the collections of object from the first set. So this we call it as a collections of set object. Now let's see that what will happen when you do run a Java applications. See, this is the outcome. This was the original set, then test1 got removed, and then you are removing that test3, test4 and test5. So if you look at, all matching got removed and the remaining one is test2. So this remove method, how it works, guys, this also we need to understand internally how it will. Same logic will work. Press control, click on remove all. So when you will click on remove all, since you are making the reference of set class, where it is taking you, it is taking you to the parent class. So wherever it has a reference, it will take you there. Okay, that's what I was saying, that at compile time call happens from the parent class. So whenever you have a reference of this guy, it will take you there, right? So again, if I'll click on remove, control and click on remove, it will take you where set.class, right? And this method is not implemented because set is the interface. Now same thing I will tell you what I will do. I'll change this to the hash set. Okay, I just change this to the hash set. Now click on remove all method. Click on remove all method. When you now click on remove all method, it came to hasset class. One thing guys, so this set class basically this set reference is of type set of this, right? So just to show you, I will do like this. Just to show you, again I will revert. Now this set1 type is what? Class type. This set is of type parent class type. This set1 is of type child class type. Now click on control and click on remove all. Okay, where it is taking you? It came to the child class this time. It did not go to the parent. This remove all did not go to the parent now, because what happens is whatever reference you will have, wherever you change the reference, and when you press control and click on the method, it will take you to that reference class. It will not take you to the object class. That's what I was trying to explain here. When this was set, okay, when this was set, what was happening? When I clicked remove all, click on remove all, it took me to the set.class, which is parent class, which is an interface. Now when I change to hasset class, and when I again clicked on remove all, it took me to the abstract set.class, because you know that set class will actually will extend the abstract set class. Why I am saying that, when you press on control and click on hasset, okay, when you scroll up, if you'll go here and you can remember these things, okay, hasset extends abstract set, implement set interface, clonable interface, and serializable interface. Okay, so these three it will implement and it will extend abstract. Now it is clear what happens when you create a reference of parent and reference of child. Your call will happen from the reference class, but yes, on the runtime call will happen from the child class if it has a method overridden. If not, then only it will go to the parent. Okay, clear? Now this remove all method, why I was stressing here is, when you click on this remove all method, press control, click on remove all, if you'll go inside, okay, look at here what happens internally. See, when you do a remove all, basically you supply collections of object, right? That's what you did. You supplied collections of object, right? This collections of object, first it will check whether it is null or not. If it is not null, it will come, it will check. Here you can see that it will check for the size and all that. Finally focus here. This is the important part. I wanted you to focus here. It is running iterator, guys. Okay, you know that on your set class you can run the iterator, and on iterator you know that it has a three method, has, next, next, and remove. So basically it is performing the remove, it is running a loop, it is running a loop, and it is doing a remove. So it will actually running the loop, it is checking the contents, right? Running the loop, checking for the contents, and then removing it. So again, when you press on control and go to the remove method here, which is iterator.class, and basically you know what is this remove, which remove method will get called? Again the same hash map has a remove method. Internally the same will get called. Again the hash code will get generated. Again it will generate the index, and again it will check the object. So again what will happen? Let's say this is the hash code. It will do a modulus of 15. It will check for the object here in this bucket. So whenever they will get the index, it will come, they will check the index in this bucket. On that bucket it will check the object. If the object is present, then your bucket.next, whatever like whatever you have seen that here, right? So whatever the in beginning bucket index.next will be pointing to some object, let's say test1, then bucket.next it will change to null, then your object will get dereferenced, and that's where it will get removed. Okay, so that's how remove all works. Now people will ask you, one interview important question is, what is the complexity when you perform the remove, and what is the complexity when you perform the remove all? So in case of when you do remove all, the time complexity will be big O of n. For remove all, the time complexity is big O of n. So this is for remove all method. Okay, So if somebody will ask you, remove all time complexities big O of n, whereas when you just have remove your time complexity of constant time, okay, remove all has big O of n. What does mean by big O of n? So when you do a remove all, and as just now I have shown you the code, so basically what happened here is, in case of remove all, let me go to the again the implementations part, click on the remove all. Okay, since we are running a for loop, so what happens for every object, whatever object you when you do a remove all, and when you try to remove a collections of object, so you can look at here, okay, from the set I tried to remove this all remove method. So what will happen, it will run iterator. So one by one it will pick up the object from the set one by one it will pick up. Let's say first it will pick up test3, okay, it will pick up a test3. Then how this internally works is, where is that abstract set, yeah, it will pick up that for, and then it will check for the contents, okay, it will check for the contents if present inside. See, again if you go to the contents also, it has implementations. Press or control, click on contents. See, again contents has their own implementations. Click on the implementations path, right? So contents has a lot of implementations. You can see it here. You can go for the one which has the map. Let's see that if you have contents implementations here. So contents here you have, right? So again you can see that it's a huge contents implementations you have. You can look at here. So it will again do a split. It will internally again it is like n times, okay. So don't go more deep into that. I'll give you the idea how it works is. So basically what will happen is, for every object when you try to remove, let's say test3 I want to remove, so it will fetch from here, it will run a loop on this set, and it will check whether this guy test3 is present here, right? If it is present, it will remove. Again it will pick test4 from here, test4 from here, it will go and run the loop here, again it will check, okay. That's how, if you look at the abstract set, that's how it happens. It runs iterator, one by one it will pick up and it will do a contents. So actually when you do internally contents, this also go and it will check your object which you are planning to remove from the previous object, right? So basically this test3 will be checked on this set object. It's a previous object, this is the latest object, okay. This latest object I want to remove from the previous one, it will go and check in the previous object, right? So that is the reason, if you look at how many times this will run, this will run actually n times. N times means this for loop will run n time, right? For every object when you are trying to delete this from set, when you are trying to delete set1, this will run n time minimum. Because it will go and check the entire bucket if any bucket has the data. That is the reason complexity will be n. And what is the n? N is nothing but the size of the bucket, okay. N is nothing but the size which is from 0 to 15. So n is nothing but the size of the bucket. That is the reason it will run n time. Whereas when you have a simple remove, it will calculate the index and it will go and check the particular index, right? So this is your remove all method. Now there is another method called, which I will give an idea of, set dot remove if, okay. There is a method called remove if. So how this remove if works? So remove if work, actually you can write a conditions based on lambda expressions. Lambda expressions mainly I will cover when I will talk about the Java 8 feature. Here I will give you an idea of how you can write a lambda expression. So you can just write set dot on this object, okay. Remove, what you can do, you can just write that, you write a parenthesis, you can see that, sorry, this is remove if, okay. Inside that you write one more parenthesis, then you write a space, hyphen, then angle, and then you write here n So in fact you don't write to this, you can just write n. If n not n, you write s, it is a string. If you write s dot contains, right, let's say test3. Okay, now what I will do, I will comment this remove all. I don't want this, I want to see the output here, what happens. So how, you know how this works, remove if. This guy actually internally, why this issue is coming, I am doing something wrong. Yeah, so how this works internally, you know, this remove if method, it will check for these conditions. So what does mean by s? You might be wondering why I wrote s and then, you know, angle bracket and all that. See, the thing is, this is the lambda expressions, which means you are saying that on the set object, you take the element one by one, which will get stored into this variable s, a string, and then on this variable, on the same variable is this variable, you are checking for the contents. So this is the lambda expression. So this is the evaluations you are going to do, right, on this variable, and this variable is nothing but the object which will come from your set. Okay, so internally if you look at this remove if method, when you go to the implementations part of this, when you click on this remove if and now click on the implementations directly, do not click for the declarations. So it has multiple implementations like this. You know that this is coming from where? This is coming from set interface. So you know that one interface will have n number of implementations in your collections. See, the set is implemented by a lot of classes, implemented by all set classes, and there are some other classes which implements this set. So whenever you go for the implementation, just press Control and hover on this, press Control, hover on this, and you have open implementations. When you click on that, you will get all sort of implementations what you have in the Java, all sort of implementations. Now I'll be interested into the map one. Why I'll be interested into the map one? Because you know that hash set internally uses hash map. Hash set internally uses hash map. So I'll be interested for the map one. So the map one, if you look at here, there we have something called set from map. So abstract set, and anything is looking map one. So sometimes if you get confusion, whenever you get confusion like this, whenever, what you do, just for your testing, go and change the reference. Whenever you get a confusion, go and change the reference of your child class type, the class which is implementing. Okay, the class which is implementing, just go and change the reference. Wherever you have a confusions of finding the implementation, I can find out because I know that, but I want you to know that. Okay, so here now go and click on remove if. Now it will take you to the class where you will have the implementations, because now you have changed the reference. Now your reference is class, now reference is no more interface. So press on Control, click on remove if. When you click on that, see, it is there in the collections.classes, which is present in the Java util package. So it is coming from collections.classes. Now this is the implementations, guys. See, look at here what I told you. It runs a loop. It runs a loop, and then what it will do, based on the conditions, based on whatever conditions you will have, it will perform the remove. So you can see that there is something called whatever filter you have supplied. Okay, whatever lambda expressions, the filter, whatever you have supplied, s contains something, right? This filter you have supplied. So whatever filter you have supplied, now this filter dot test. Okay, test. So you can look at that. This is nothing but predicate. Okay, this is nothing but predicate which you supplied dot test on the object. So what is test? So press Control, click on test. When you go to the test, see, this is there in the predicate, and this is coming from Java 1.8, as that's what I was mentioning it. So there is a predicate. This test, what it will do, it has an implementation. This test will check actually whether this conditions is matching or not. So you can go into the test. There is an object for anonymous inner class. So click on new predicate, and again this came as a part of Java 1.8. This is the source code you have, the source code is not downloaded in my system, so this method is not getting loaded. Okay, so that's how it works, guys. Okay, now you got it. You can look at here, evaluate this predicate on given argument. It will evaluate parameter is t is the input argument. If the input argument matches the predicate, whatever predicate you have supplied, it will return true, otherwise it will return false. So see here, the return type of this predicate is boolean, so it will either return true or it will return false, right? So now come back here, what happens when you perform remove, or again press or control, click on remove if. So this predicate, it will either give you true or false. So you know that if conditions means it will work only with true or false. So when you performed predicate dot test, so basically it will go and check these expressions on the object. If that object is conditions is met, okay, if the conditions is fulfilled, the particular object, whatever filter you have supplied, that filter and whatever object, when you are running a while loop on the iterator, if both matches, remove it. Okay, so what is the time complexity here? Big O of n. So time complexity is big O of n. Why I am saying that the worst time complexity is big O of n? Because to match this, it will run a loop on your set. It will run a loop on your collections of object of the set. So your time complexity for the remove if method is nothing but big O of n. So if someone will ask you someone will ask you what is the time complexity for this guy remove, the time complexity for remove if, let's say. So please remember this, these are the very important point which I am talking about. So let's say you have remove if, time complexity will be big O of n. They will ask you why. Say that because it will run a iterator and then it will try to match the filter conditions what we have given. If it matches, which means it will run the entire, it will run on the entire set. Okay, and when it will run the loop, see, not only it will just check for the conditions, once the conditions is fulfilled, which means if this particular object which you are looking for, whatever filter you are looking for, if this filter is found, then it will call a remove method, which you have seen that internally it calls a remove method. Now you also know that this remove method, when you go to the implementations which we have in the hash map, this remove method which we have in the hash map. So how you can go from here, I can tell you this, you click on this remove, not this, click on control, click on remove if. So when you click on remove, click on the open implementations. When you click on the open implementations, multiple implementations will come here. You can go for which has a map implementations, right? So you can look for the map class. Why I am saying that map? Because internally it uses hash map. So you can search somewhere, you can look for hash map. Can you see that anywhere? Yeah, I cannot. But in general, these are the things, these are basic things which you can remember. Okay, because it performs on the map. So again, do one thing, click on remove. This is the remove and open declaration. So it will take you to the declaration. Don't go there, you don't need to search all that. Please remove that. Please remember that internally this implements hash map. So when you come to the hash map, it will call this remove, and again same thing will happen. It will generate a hash code, it will look for the index, and again it will deassociate the object, right? So with this we are done with all remove method from the hash set. Now what I will do, whatever actions I have performed, right, and I will go back and I will change this to the set. So assume that this was the set. Okay, can I change whatever set I have? If I will change to linked hash set, what I did, I changed to the linked hash set. So now this implementation is linked hash set. this implementation is hash set. Okay, this implementation is hash set. I will keep this on. Okay, and let me run that, see that what happens. So first implementations you have for the linked hash set, the second you have for the hash set. Even in that case it will work fine. There will not be an issue, both the method will work fine. Either you have the implementations of hash set or linked hash set, because internally both the classes linked hash set and set will implement the set class, right? And if it implements the set class, both will work fine. So let me do one thing, let me not change this for your reference so that you can study later. What I will do, I will copy the entire thing. For all remove method, I will go here and I will change this to linked hash set. Okay, I will go here, I'll just change this, I'll make it small so there will not be any confusion. So why keep on I am covering all three, so that you can see the difference. Otherwise if I will do separate, you will not come to know why these three classes came, what is the difference and all that. You will not come to know. Same you call on this, you call this remove. Okay, and on this you call remove if method. So after this removal, do one thing, add 3 also. Again, because 3 you are removing here, or do not remove 3 from here. So you will have 3 in the set, so that after this you can look at the output also. Okay, change this print set to linked hash set. Yeah, cool. So if I run this, see, you can look at the output. So before that, do one thing, SYSO, control space bar, and write some demarcations in the output. So you can see that I just wrote one demarcations here. If I go here and run that, right, it works fine. There is no issue at all. I will do here remove set also, and here also I will not remove the 3 because 3 I am removing after that. So if you look at whether you have a hash set or linked hash set, okay, the difference only what you can see that is, in case of linked hash set, the insertions order was maintained, test 1, test 2, test 3, 4 and 5, which we have done here. So insertions order was maintained in the linked hash set, whereas in the hash set the insertions order was not maintained. But your both operations, the remove and remove all went fine. Here also after remove all, your order is not maintained, but here after removal also the order is maintained. So in case of linked hash set, always order is maintained. If you will just change linked hash set to tree set, nothing will happen, only your order will be in the ascending order, right? So with this we are done with all remove methods in the linked list hash set class. Thank you guys, thank you for watching this.